Hello. Alright, we're here to go for one final thing involving graphs. Okay. Hopefully everyone is alright. Hopefully you're all doing fine. Hopefully that you are all well. Okay. We're, as I said, going to look at one final thing to do with graphs today. And this should be a relatively short one. Okay, because the whole idea of this is solving equations using graphs. Okay, and the key for this is just kind of using the knowledge that you've accumulated so far, and also thinking about your ability to check your answers as well. Okay, so we're going to go for solving a range of different equations. Starting off with things like solve 3x plus 2 is equal to 11. Okay, equations which you may have been solving for quite a long time. Okay, we're also going to look at equations where we might have 4x plus 3 is equal to negative 2x plus 7. Okay, something like that. Okay. And we could, as well, we're going to branch out into solving simultaneous equations. So solve simultaneously 2x plus y equals 8 and 2y plus x is equal to negative 4. Okay, something like that maybe. Now, the method for solving any kind of equations by using graphs is to really look carefully as to what graph you need to draw or what graph you need to think about. Okay. For instance, if you're looking at this graph here, if you remove the 11 part of things, we have 3x plus 2, which is almost like a straight line graph by itself. Okay, and indeed, if we type in y equals 3x plus 2 into our graphing software just to the left, we can see that we get a line. Okay. Now, what we need to think about is we need to think about when this thing is equal to 11. Okay. Now, the thing that we have here, that 11, that is effectively our y value, because we have our x values and things here, like we would for a normal straight line graph. The thing that we were missing was our y value. Okay, so in this case, we're having to scroll up until we get to our y value of 11 up here, scooting across until we get to that point B over here, and then dropping down to figure out what value of x we would have to get. Okay, so for that first one, we've needed to plot 3x plus 2 is equal to y. Find where y is equal to 11, and then drop down to find the value of x. Okay. Now, if we look at the coordinates for this point B here on the side, we have the coordinate 3, 11. Okay. Now, that 11 is the y value of 11, which is from the equation we were trying to solve, and the x value is the value of x that we would need to give us that y value of 11. Okay, so in fact, if we look at just those two bits, the line 3x plus 2 and the line where y is equal to 11, where they cross over is the point where the two lines are equal. Okay, so this point B, where we have B. So at this point B, where we have x is equal to 3 and y is equal to 11, that value of B is effectively our solution. Okay, where we get that value there. Okay, so effectively, what we kind of get is we get the point where the two lines cross over. Okay, and we are looking for that point in order to find out our value of x that we are looking for. Okay. Or plot y equals 3x plus 2 and y is equal to 11 to find the crossover. Okay. And this idea of equations crossing over one another is the thing that we are looking for when it comes to solving equations using graphs. Okay. Because we could change our value of, we could change the value that we have got our equation equal to. We could change this from being 11 to being 8. Okay, and we would then have to think, okay, if I have a y value of 8, okay, like that. Okay, going straight across here, where they cross over will be the point where 3x plus 2 is equal to 8. Okay, so that point there. Okay. Now, if we start to get more complex equations, we just are continuing to look for the point where these two equations cross over, where they intersect. Okay, so for example, this equation here, where we have 4x plus 3 is equal to negative 2x plus 7. Here we've got two sides of the equal sign, both with their own x plus something, you know, like an equation of a straight line, just missing the y's. Okay, so we've got two different equations for us to graph, which means that we'll have a point where everything crosses over. Okay, so let's have a look at that. Let's see how this works. So we've got one side of our equals sign, which says 4x plus 3. Okay. Like that. So this line here has a gradient of 1, 2, 3, 4. Intersects the y-axis at 3. And we've got a second equation on the right-hand side, which is negative 2x plus 7. Okay, and comes down like that. It has a gradient of negative 2, so 1 whole unit across, 2 whole units down. And it crosses through the y-axis at 7 from the number at the end. Now, when these two things are equal is where they're going to cross over. Just there. Okay? And if I scoot my screen across a little bit, it's got the point A, which is the intersect of these two lines. Okay? And we get our values of 0.67 and 5.67. Okay? So they intersect when x equals 0.67, which is going to have been rounded up from 2/3, and when y is equal to 5.67, or 5 2/3. Okay, because again, it will have been rounded up. Okay, and let's just scoot that back. There we go. So that point A here, where the two things cross over, that is effectively our solution to those two lines, to this equation here. We've graphed each line separately and then used the crossover point for us to find out what value of x must we have had to make them equal to one another. Okay, so we can solve equations, like simple equations like this. We can solve equations where we have like unknowns on both sides. The question now is, how do we solve things like this, simultaneous equations, which you look at in year 10 and year 11? Well, there's only one thing that we can do, really, and that's to graph them. And if you're wanting to graph things, it's a good idea to make sure that you have everything in the, in the right format. Okay? And the format that we look to use things in is the format where the graphs are written as y equals mx plus c. So let's see one of those in action. See. So let's solve 2x plus y is equal to 8. 2y plus x is equal to negative 4. And let's call this equation 1 and this equation 2. Now the problem that we have is that they're not written in the form y equals mx plus c, so that's what we're going to have to do. We want to get these into the form y equals mx plus c. So for equation 1, we're looking to try and make y the subject. The only thing stopping that from being the subject is the 2x. I'm going to have to take off 2x from both sides. So take away 2x. Take away 2x from both sides. We're going to get 8. Take away 2x. Okay. And for the second equation, we've got 2y plus x is equal to negative 4. We want to make y the subject. So I've got to undo the addition of x. I need to subtract x from both sides. So 2y is equal to -4 take away x. But I don't want just y. I have to make the y be the subject by itself, completely by itself. So we divide it by 2. So -4 divided by 2 is -2. And -x divided by 2 is -x over 2, or half of an x. And we've got to think of ways that we can now graph this. Okay, let's suppose that we've been given some graph paper in an exam and we're trying to graph these things. Let's use what we know about y equals mx plus c. Okay, for equation number 1, the y-intercept is 8. The gradient is -2. So let's put that information in. When it crosses through the y-axis at 8, and it has a gradient of -2. So for every unit we go across, we go 2 steps down. There's our line. Let's have a look at the other one. We've got a y-intercept of -2 and a gradient of -1/2. Okay. So again, let's have a look at this. So let's go down to where y equals -2. There. And the gradient is -1/2. So we're going to be going down. And remember our rise over run. So for every 1 box that we go down, we're having to go 2 boxes across. So 1 box down, 2 boxes across. Just like that. Get our line together. Boom. Okay, and we can see that that creates our nice little gradient of 1/2 of a box. And we get our crossover point. Perfect. Let's put a little intersect dot down just there. And if we take a look at the coordinates of that crossover point, E, just here, which we're going to make bright pink. Okay, we get a value of x to be 6.67 and y to be -5.33. Okay, and remember, when we're dealing with simultaneous equations, we're not just looking for a value of x, we're also looking for a value of y. Okay, and you know, we can then kind of graph pretty much anything. Okay, so long as we have a technique for graphing it, then actually we can solve equations with it. Okay, much easier if we've got graphing software, yes, but if we've got like a table of values to draw a quadratic curve, we can use that. If we've got the form y equals mx plus c for a straight line, we can use that. So long as we have a method to graph something, then we can go ahead and solve equations with it. Okay. Yeah. I mean, you could even go so far as to solve quadratics using graphs. Okay. And we're going to talk about this a little bit as well moving forward. So for the future, we could be thinking about solve x squared plus 4x plus 5 is equal to 6. Okay. And you can think of as this to graph, and this is our y value. If we're just going to look at that quickly, we've got some graphing software with us, we can all type it in. So we've got the x squared plus 4x plus 5 to graph. Oh, wait, that's come out wrong. X squared plus 4x plus 5, like that. And find the value when y is equal to 6. Okay? And if you know about solving quadratic equations, you should know that you get 2 values of x, and we absolutely do. Okay, we get one value there, and another value there. Okay, so this is thinking towards the future a little bit. We're going to be looking at quadratic graphs and things like that, moving a little bit forward, thinking about going ahead. Okay. But if you can identify what part of the equation you need to graph, what part of the equation we need to kind of look up our y-axis for, this is all right, really. It's not one of the worst things to kind of look at in terms of maths. It's quite nice. So further here, that's like the equation that we graph. So this must be the y value that we're looking to find. We've got two different parts of our equation here. We could get all of the parts to one side, or we can just graph them all separately. And then for solving simultaneous equations, once we've got them in the form of y equals mx plus c, then we can look to graph them, perhaps using the gradient and intercept method that we've looked at before. Okay? And yeah, there are kind of lots of useful things for doing this, because believe it or not, when we get to some extremely advanced parts of maths, being able to model them and kind of do things using algebra isn't always the easiest thing to do. So doing things graphically or solving things numerically actually is kind of very useful technique. And this is kind of one of those bedrocks of doing that, so that when you perhaps look at some really, really funky equations, you at least have a sense of what you're trying to look for, trying to find points of intersection, trying to find crossover points, and see what those values give you. Okay? As I say, a little bit of a shorter video today, a bit more of a kind of show and tell. And if you want to play around with this graphing software yourself, you can. If you just go to geogebra.org, in fact, I will show you very quickly, just in case you're curious and you want to have a look at it for yourself. If you go to geogebra.org, okay, and if you download GeoGebra Classic, which is in the middle there, you can get the graphing software which I've been using. Okay, and you can type in equations on the left-hand side, and you can then use those to find the crossover points. Okay, there we go. Really useful, and if you want to have a play around with it, it's quite good. It's reasonably fun. Okay, so yeah, I'm going to leave that with you. Have a nice Friday. Have an enjoyable day. I shall see you all next week.